Hi guys, and welcome to part 2 of this video on algebra rules. If you've not managed to check out video 1, then I highly recommend having at the very least a little gloss over that video. So let's continue with the concept of zero. So what we have in front of us is a formal rule inside this blue box. This rule is known as the identity of addition, and what that rule means is when we add 0 to any number, we do not change that number. So for example, a plus 0 equals 0 plus a equals a. So adding 0 to a here or adding 0 to a here still results in an unchanged a. Right, let's move on to the inverse of adding, which will drive that concept home a little bit better. So when we apply the inverse of an operation, what it does is it undoes an operation. So let's work with these numbers here. We've got 5 plus 4. To undo that operation, or to get back to your original 5, we must add -4. So if we see here, if we see 5 plus 4 plus -4 is 5 plus 0, because these cancel each other out. A +4, subtracting a -4 from the +4 equals 0, if that makes sense. So we've got 4 plus -4, or when we rewrite this out, what this means is 4 minus 4. So we effectively undo that operation, or it's the inverse, and we're just left with 5 here. So to rephrase this, we can say that adding -4 is the inverse of adding 4, and vice versa. We say that -4 is the additive inverse of 4, and 4 is the additive inverse of -4 as well. So in general, corresponding to every number a, there is a unique number, -a, such that, and here comes the rule. So if we read this on and we flow into this section here, we're saying to every, in general, corresponding to every number a, which is here, there is a unique number, -a, such that when it's added to that number, it produces 0. So a number combined with its inverse gives the identity. So let's just go over this one more time. So here's a number. If we add the negative of that number, we are effectively undoing that operation, and we're finally yielding the value 0. So just to recap, the additive inverse of a is -a, and the additive inverse of -a is a, which makes sense. So let's do a few problems. Oh, before we go on to these problems, let's just take a look at this here. So what you've got here is this minus sign. There is an implied 1, which sits just between this minus and this parentheses. And that 1, when we say -1 multiplied by, again, here we have an implied 1 here. -1 multiplied by -1 is 1. And then we know that 1a equals a, because multiplying any number by 1 does not change that number. So let's move on to a few problems. Problem 4 says transform each of the following according to a rule of algebra. So we have, what's this? This is x, y, z plus 0. I mean, adding 0 to any number does not change that number, so we should still be left with x, y, z. And what about this? If we subtract -q from 0, what do you think we have? We have -q. If we add 0 to this negative fraction 1/4, then we still get -1/4. The number -1/4 does not change. What about the additive inverse here? So we've got half, and if we add -half Or let's rephrase that as a half. Take away a half, it makes sense that we would get to 0. And similarly, we have negative PQR plus PQR. So if we add the additive inverse to negative PQR, we must be left with 0. What about this one then? So we have, if we look, we've got 3 terms. We've got X, we've got ABC, and we've got ABC here. So if we look here, we've got a positive ABC, and we're subtracting its additive inverse, which will produce 0. So this whole thing produces 0. And if we add 0 to any number, we should still get that number. And I'm just going to gloss over a few of these. And I'm going to scroll down a bit. And PQ plus what equals 0. So we have to think about this. What do we add to PQ to produce a value 0? We add the additive inverse, and if this is an assumed positive, then the additive inverse would be the negative of this, which is PQ plus negative PQ equals 0. So excuse me, I've just inadvertently, where's the reload button? Inadvertently done that. So what must we add to negative Z to get to 0? And you've just seen it's a Z, so we'll just skip that. And we've got some weird symbolage going on here, which you might not typically see in a textbook, but we've got the ampersand, the symbol 2, and the dollar sign. And these are factors. So ampersand, 2, and dollar sign, sorry. So what must we add to that to produce 0? Again, negative of that, or the additive inverse. So I'm just going to leave those for you to ponder over, and we're going to move on to the 2 rules for equations. Right, so let's deal with a few rules for equations then. So when we have an equation, we know that whatever's on the left of the equal sign must be equal to whatever's on the right of the equal sign. So that is a brief definition of what an equation is. It's something what's equal, so something is equal to something else. In this case, for this rule, we're saying that A is equal to B. And what we're going to be saying in this rule is if we do something to one side of the equation and do the exact same thing to the other side of the equation still hasn't changed. It is still equal. Whatever's on the left is equal to whatever is on the right. So the rule means, let's take a look at this. So here we have A equals B. If we add C to A on the left hand side of the equation, and we add C to B on the right hand side of the equation, we have not changed the equation. We've just changed the form of the equation, what it looks like. So the rule means we may add the same number to both sides of an equation. So if I scroll down, give a concrete example of what I'm talking about. Right, example 3. So we've got this equation, x minus 2 equals 6. So then if we subtract 2 from this side, which is the same thing as adding 2, so if we were to add 2 to negative 2, we would cancel this negative 2 out. Remember what we briefly just spoke about, the additive inverse. So if we apply the additive inverse to negative 2, we can undo this operation. And similarly, if we add 2 to the 6, then we get x equals 6 plus 2, which equals 8. So upon adding 2 to both sides. That seems a bit confusing to explain without pen and paper, but all I did is add 2 here to cancel this negative 2 out, and I had added 2 to 6 to produce 8. And we'll move on to example 4. So in this example, we've got x plus 2 equals 6. So if we subtract 2 from this side and subtract 2 from this side, we end up with x equals 6 take away 2 equals 4. Hope that's straightforward enough. We've just added the additive inverse to this 2. So we've just added 2 and then we've added negative 2 to cancel this 2 out. So upon subtracting 2 from both sides. So it says, but the rule is stated in terms of addition. Why may we subtract? Well, if you remember in the past video, because subtraction is equivalent to the addition of the negative. So what we have here is a minus b is in actual fact a plus negative b. We are adding a negative to form a subtraction operation. Hope that's clear. So therefore, any rule for addition is also a rule for subtraction. Let's have a look here. No, in example 3, adding 2 is the inverse of subtracting 2, and the effect is to transpose negative 2 to the other side of the equation as positive 2. If that's a little bit confusing, transposition is just when we subtract 2 here, we can transpose this over to the other side, and transposing changes the sign of the term. So if I move that over to the other side of the equation, we must flip the sign of this particular term. So that's all transposition is. Right, so let's just do a few problems. If x minus 1 equals 5, then x equals, we need to get rid of this negative 1, so we add 1 to the left-hand side, and if we add 1 to the right-hand side, we get x equals 6. b, x plus 1 equals 5. We're trying to isolate x here. So to get rid of 1, we must add the additive inverse or subtract 1. So x plus 1 take away 1 equals also, we must subtract 1 from 5. So x plus 1 take away 1 here equals 5 take away 1, which equals 4. So this one is on adding 1 to both sides, and this one is on subtracting 1 from both sides. So here we have x minus 4 equals negative 6. So we need to get rid of this negative 4. So we add 4. So we add, if we add 4 to this side, we must add 4 to this side. So x minus 4 plus 4 equals negative 6 plus 4. Because we added 4 on this side, we must add 4 on this side. So negative 6 plus 4 is negative 2. And we'll do another one. D, x plus 4 equals negative 6. So we want to be taking away 4 here to isolate the x. And if we take away 4 here, we must take away 4 here. So negative 6 plus negative 4 is negative 10. This is on adding 4 to both sides, and this is on subtracting 4 from both sides. And we'll move swiftly on to rule 2. If A equals B, then if we multiply A by C, and we multiply B by C, i.e. we're multiplying both sides by C, the equation does not change. So here's an example. 2x equals 3. What have we done to this side? We've multiplied this side by 5. So we therefore must multiply this side by 5 to maintain the equality of the equation. So it says now what happened to 2x to make it 10x. So how did we get to 10x? We multiplied it by 5. Therefore, to preserve the equality, we must multiply 3 by 5 also. Otherwise, we have changed the equation. So 10x equals 15. And in example 6, we have x over 2 equals 5. And we need to get rid of that 2 in the denominator of the fraction of x over 2. So we must multiply the left-hand side by 2. So if you can imagine a 2 here, The 2's will cancel. So if we multiply the left hand side by 2, we must also multiply the right hand side by 2, which produces x equals 10. So the 2's cancel on the left hand side through multiplication of 2. If you remember, if we have a factor in the numerator that's equivalent to the factor in the denominator, we may strike a line through those and cancel those factors to make calculations much quicker. And here we've just multiplied both sides by 2. The 2's cancel. We won't go into that because ideally I need a pen and a paper to demonstrate that, but we will move swiftly on to example 7, and we have 2x equals 14. So to isolate x, we divide the left hand side by 2, and therefore we must divide the right hand side by 2. This is getting a little bit into equations too much for this video, so I'm going to just gloss over these, and I think we can scroll down and let's see what we have here. Okay, let's move on to this rule. So in any equation, we may change the signs on both sides. So if we have negative a equals b, then we can say a equals negative b. And if we flip these over or transpose them again, so if we move the negative b over to that side and move the a over to that side, we must flip the signs of those individual factors or terms. If you enjoyed that video, don't forget to hit that subscribe button, leave a like and comment down below what you'd like to see next. Over and out.